This call is now being recorded.
Okay, so good afternoon all. So in the last lecture, we have started the numericals or the problems based on the strain energy and the impact load. So in the previous lecture, we covered the three important derivations. Derivation number one, which is related to the stress due to the gradually applied load, in which we have derived the formula that is sigma equal to P upon A. Then second derivation we have derived, that is stress due to suddenly applied load, that is sigma equal to 2P upon A. And third derivation we have derived related to the stress due to the impact, and for that having the formula that is sigma equal to P upon A in bracket 1 plus square root of 1 plus 2H upon delta L. So these three derivations we have discussed or we have derived in the last lecture. In addition to that, this is the list of the formulas which we have to use for the or for solving the numericals based on the strain energy and the body. Okay, so this table in the last lecture I have given. Okay, so this particular table, it is given in the last lecture, so which contains all the types of load, and if your member or if your body is subjected to the respective loading at that time, how the stress induced or how the maximum stress induced in that particular body, it will be calculated. My voice is breaking?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Wait, I will rejoin it. Now it is audible, please check.
Yes, sir.
Okay. Okay. So in the last lecture, this particular table I have given just for your reference, or this table indicates the important formulas to solve the numericals based on the strain energy. So the second column, it represents the type of loading. Then third column, it represents the stress developed in that particular body, that is sigma is equal to. The third column, that is change in length. So to calculate the change in length, the formula delta L is equal to sigma L upon E. This formula is same for all the three conditions. And the last column, it represents the strain energy in the body. That is capital U is equal to sigma square upon 2E into volume. So the change in length and the strain energy in that particular body, these two formulas, it will remain same for all the three conditions, that is gradually applied load, suddenly applied load, and the impact load. Only change in the maximum stress formula, that is sigma is equal to something. Okay, and again the two formulas I have given, that is proof resilience, the maximum strain energy stored in the body within elastic limit is called as a proof resilience. And then one more formula I have given, that is we have to solve some of the numericals based on this particular kinetic energy also, that is kinetic energy is equal to 1/2 mu square if the mass is not given and the load applied on that particular body is given at that time. So to convert that particular load into the mass, that is we have to use 1/2 P upon G. That G we have to take it as a 9.81, which is in meter per second square. Okay, and this V, that is velocity or the speed of the body, is also given in the statement, and by using that particular given parameters, we have to calculate the kinetic energy. And based on this particular concepts, in the last lecture we have solved one problem. Whatever the problem we have discussed in the last lecture, that problem is based on the suddenly applied load. That is, one circular bar is there, and That circular bar, it is having length 2 meter and it is having length 2 meter and its diameter is 25 mm. It is given in the statement. And whatever the axial pull means that particular member or that particular bar, it is subjected to the tensile load of 15 kilonewton, which is applied along the axis. Whatever the 15 kilonewton load is applied, it is applied along the axis and it is applied suddenly. So gradually, suddenly, and impact. These three words are very important to understand the statement. Now here in this particular numerical, whatever the 15 kilonewton load is applied, it is applied suddenly, and we have to calculate which parameter? We have to calculate the maximum stress induced due to the suddenly applied load and the total elongation of that particular bar. So whatever the given parameters are there, that is length is given, diameter is given, P, it represents the suddenly applied load, Young's modulus is given, and we have to calculate the sigma and we have to calculate the delta L. And as we are having the condition that is stress due to the suddenly applied load, so we are having the formula of the maximum stress calculation, that is sigma is equal to 2P upon A. So 2 is the constant parameter, P into 15 into 10 raised to 3 divided by area for the circular section, pi by 4 d square. We have calculated the stress value, and then due to that particular stress or due to that 15 kilonewton suddenly applied load, the elongation of that particular bar is also taking place. The elongation for same for all the three conditions, what will be the formula? That is delta L is equal to sigma into L divided by E. The sigma just now we have calculated by the suddenly applied condition. Length is given, Young's modulus is given. By keeping the all value, the total deformation is equal to 0.611 mm. So this is the problem, one sample problem we have discussed in the last lecture only, which is related to the suddenly applied load. Now again today we will solve some of the numericals based on the stress due to the gradually applied load and stress due to the suddenly applied load. Now this is the second problem in front of you. So we'll read the statement carefully and then we will solve. So now read the statement. A tensile load of 60 kilonewton is gradually applied. A tensile load of 60 kilonewton is gradually applied to a circular bar. Again, whatever the bar is given, it is circular in cross section. So whatever the 60 kilonewton force is applied, it is applied gradually. Again, double underline. Whatever the load is applied, it is applied gradually on circular bar of 40 mm diameter and 5 meter long. So whatever the circular bar is there, it is having the 40 mm external diameter and 5 meter long, full stop. If the value of E is equal to 2 into 10 raised to 5 Newton per mm square, full stop, determine stress in the rod, elongation of rod, and strain energy stored in the rod. That means three parameters to calculate. So what is the statement? Is one circular bar is there, and that circular bar is subjected to the external load of 60 kilonewton, and it is applied in gradual condition. It is not applied suddenly. It is not applied like an impact. It is applied gradually. Gradually means the load is increases from 0 to maximum point in a stepwise condition. So that load is called as a gradually applied load. So as per the statement, we'll write some given parameters. What will be the given parameter? P is equal to 60 kilonewton, that is 60 into 10 raised to 3 Newton, which is applied gradually. This is the gradually applied load. Then diameter of circular bar is given 40 mm. Length is given 5 meter. So we have to convert in mm, that is 5000 mm. Young's modulus is given 2 into 10 raised to 5 Newton per mm square, and we have to calculate stress in the rod. Again, we have to calculate the deformation of the bar, and we have to calculate strain energy stored in that particular bar. That means these three parameters we have to calculate. Okay. Now, as per the condition, whatever the 60 kilonewton force is applied, that 60 kilonewton force is applied in gradual condition. So, we are having the formula, that is as per gradually applied load. As per the gradually applied load, we are having the formula sigma is equal to P upon A. So this is the formula for the gradually applied load. So P is given 60 into 10 raised to 3 divided by area pi by 4 into d square means 40 square. So what will be the stress value? Please do the calculation and tell me the stress value. Then elongation of rod. Elongation of rod in bracket delta L. Therefore, delta L is equal to sigma L upon E. Yes, stress 47.74. Yes, correct. 47.74 Newton square. Please check your answers. Those who are solving. 47.74 Newton per mm square. This is the stress induced in the bar due to gradually applied load. Now find the elongation of rod. Elongation, we are having this common formula delta L is equal to sigma L upon E. So sigma just now we have calculated 47.74 into length, which is converted in mm, divided by 2 into 10 raised to 5. Then find out the elongation. Delta L is equal to, find the elongation, yes, 1.19. 1.19. 1.19 mm. This is elongation of rod due to 60 Newton grad applied and due to the maximum stress developed bar. And strain energy. Okay. Strain energy. Strain energy, which is indicated by the capital U. So we are having the formula. Capital U is equal to strain energy formula sigma square upon 2E into volume. Okay. Then sigma square upon 2E. Volume means volume for the circular cross section, that is area into length. Getting? Now put the values. U is equal to sigma square 47.74 square divided by 2 into 10 raised to 5 into area pi by 4 into 40 square. This is area into length 5000. Now find out the total strain energy stored in the rod. Total strain energy stored in the rod. We are having the formula sigma square upon 2E into volume. Volume means area into length. What will be the answer?
35.8. 35.8 into 10 raised to 3.
35.8 into 10 raised to 3 Newton mm. Newton mm. 35.8 into 10 raised to 3 Newton mm. This will be the strain energy stored in the circular bar due to 60 kilonewton gradually applied load. So whatever these three parameters are developed, sigma, this is due to the 60 kilonewton gradual load. Again, elongation, this is also for the 60 kilonewton gradually applied load, and whatever the amount of energy stored, that is U, that strain energy is stored due to the 60 kilonewton gradually applied load. Please do for the strain energy U. Tell me the answer in the chat box. Don't look at the things, only try to solve the problem. Solve the problem, you know. Yes, give me answer. Yes, 35.80. The 35.61, it depends upon the digit. Sometimes you will get the 35.80, only 8, then 35.61, like that. It depends on the digit, how many digits you are considering. So your answers will be different. Yes, solve it immediately. Yes, 35.80. Others, what is your answer, please? Yes, traces, then elongation, and U. The problem is like previous one only, but in the previous or in the problem number 1, whatever the load is applied, that load is suddenly applied. Therefore, due to the suddenly means we are changing the stress formula. Sigma is equal to 2P upon A. But here, in the statement, whatever the load is applied, that load is gradually applied load. Therefore, for the gradually applied load, we are having the formula sigma is equal to only P upon A, not 2P upon A. So please use the formula from that particular list and solve the problem. Yes, 35.80 into 10 raised to 3 Newton mm. Try to write down the unit also. 35.80 into 10 raised to 3 Newton mm. Okay. Okay, I hope you have solved. Now, the next problem, just for you, for your solution. So read the statement carefully and try to solve the problem. So I will read the statement. Just see. The uniform metal bar has cross-sectional area 100 mm square. The uniform metal bar has cross-sectional area 700 mm square and length 1.5 meter. So whatever the cross-sectional area is given, directly the cross-sectional area value is given 700 mm square. The length of that particular section is also given how much? 1.5 meter. Stop. If the stress at elastic limit, if the stress at elastic limit is 160 Newton per mm square. The stress at elastic limit is 160 Newton per mm square, full stop. What will be the proof resilience? What will be the proof resilience? Full stop. Determine maximum value or suddenly exist in elastic limit. So,
Your voice is breaking.
particular member it is okay. Okay. So, whatever the cross section is considered, that particular cross section it is subjected to the 160 Newton per mm square as a stress value which is developed within the elastic limit, and we have to calculate what will be the proof resilience developed in that particular body, and also we have to determine the maximum value or calculate the applied load. The problem is opposite. Whatever the previous problems we have solved is gradually applied load or suddenly applied load. It is in the statement.
Sir, voice
Gradually
is
applied
breaking.
load and suddenly applied load. Given in the statement.
Voice break हो रही है.
Okay. Now it is clear. Okay. So whatever the statement is in front of you, in that this particular numerical is exactly opposite to the previous two numericals. In the previous two numericals, the gradually load and suddenly applied load, it is given in the statement as a given parameter. But here in this particular statement, they have given the stress value, and by using that particular stress value, we have to calculate the proof resilience, as well as we have to calculate the maximum value or the value of suddenly applied load. In previous two problems, the load value is given to you, and from that particular load value, we have to calculate the stresses induced in that particular bar. But here, it is exactly opposite. The stress induced in that particular section, it is given, and we have to calculate how much amount of suddenly applied load is in that particular body. So this is the statement in front of you. So if I will write down the given parameters, just see, whatever the cross-sectional area is given, directly area value is given. How much? 700 mm square. This is the cross-sectional area. Length is equal to 1.5 meter is equal to 1500 mm. Then sigma. What if the stress at elastic limit, sigma, that is 160 Newton per mm square. This is the stress value given, and in addition to that, the constant parameter E is also given. How much? 2 into 10⁵ Newton per mm square. And we have to calculate the proof resilience, which is indicated by Umax. So Umax we have to calculate, and in addition to that, we have to calculate the P, which indicates suddenly applied load. Okay, so whatever the stress is applied, the stress within it as a sigma max, because the elastic point is the maximum limit, because once your body will cross the elastic limit, and if I will remove the load, body does not regain to its original position. Whatever the body regain to its original position, it is possible within elastic limit only. And also we are having the definition of resilience, as well as we are having the definition of proof resilience. What is the definition of resilience or the strain energy? The total energy stored in the body within elastic limit, that energy is called as strain energy. And proof resilience means maximum energy stored in the body within elastic limit. This is called as a proof resilience. That means in both the conditions, your elastic limit or within elastic point, this word is very important, because once your body will cross the elastic limit point, and if I will remove the load, body does not regain to its original position. Therefore, in this particular numerical, your sigma is also represented by the sigma max. So we have to calculate U max, that is proof resilience, and we have to calculate the capital P. Okay, now we'll calculate the U max. The first parameter, proof resilience. Proof resilience, that is Umax. Proof resilience Umax is equal to, we are having the formula, Umax is equal to sigma max square upon 2E into volume. So sigma max means 160 square divided by 2 into 10⁵ into volume means area into length, that is pi by 4, into your area value is, or directly area is given. Here there is no circular cross section, area into length. Therefore 160 square divided by 2 into 10⁵ into area 700 into length 1500. Yes, Umax, I think everyone has represented the answer. Umax is equal to how much? Yes, 67.2 into 10⁵, correct. 67.2 into 10⁵. Unit is again Newton mm. Unit is Newton mm. So this represents the Umax, that is proof resilience. So simple formula we are having. What is the formula we are using for the strain energy? U is equal to sigma square upon 2E into volume. But here we are calculating the proof resilience, which is represented by the maximum condition, that is Umax is equal to sigma max square upon 2E into volume. Then suddenly applied load. Suddenly applied load, that is P I have to calculate. So which formula I have to use? Sigma is equal to, what is the formula for the sigma is equal to 2P upon A. Sigma is equal to 2P upon A. Sigma is given 160. 2 into P is the unknown parameter, cross-sectional area 700. Therefore, capital P is equal to 160 into 700 divided by 2. Therefore, P is equal to how much? What is the value of P?
56
Yes,
into 10 raised to 3.
Yes.
56 into 10 raised to 3 Newton.
56 into 10 raised to 3 Newton is equal to 56 kilonewton. So many of you have calculated the answer P is equal to 112. It is wrong. Please check which formula we have used. Whether you have used the sigma is equal to P upon A or whether you have used the sigma is equal to 2P upon A. Here in the statement, please see. Determine the maximum value or suddenly applied load. They have given the word suddenly applied load. Therefore, while using the sigma formula, what will be the formula for the sigma? Sigma is equal to 2P upon A. If we are using the P upon A, that formula will be applicable for the gradually applied load. If we are using that formula, your final answer will be wrong, because they have mentioned the condition, that is find the maximum value or suddenly applied load. And for the suddenly applied load, we are having the stress formula sigma is equal to 2P upon A. And by the calculation, you will get the answer 56 into 10 raised to 3 Newton, which is equal to 56 kilonewton. Answer at 112 kilo. We have used the formula sigma is equal to P upon A, but P upon A is not applicable. Yes, 56 into 10 raised to 3. Now it is correct. So please read the statement carefully. Which word is mentioned, whether gradually applied load is mentioned or whether suddenly applied load is mentioned. That understanding is very important. If you are missing that particular part, your answer will be wrong. So please read the statement carefully and identify the word gradually and suddenly. Make the double underline to them so you can easily understood that this particular numerical is based on the gradually applied load or this particular numerical is based on the suddenly applied load. So please do the calculations. This third number problem, it is exactly opposite to the previous two problems. In the previous two problems, either gradually applied load or suddenly applied load is given to you and stress we have to calculate. But this problem is exactly opposite. Stress is given to you and by using that particular stress value, we have to calculate the load. But which load, whether suddenly or gradually, that first of all we have to identify from that particular statement. Now in this particular problem, they have mentioned the word to find the suddenly applied load. Therefore, we have used the formula sigma is equal to 2 upon T. Okay, so this is the statement. Have you solved? All of you have solved this particular numericals? Only few students are solving, others they are not responding in the chat box. Try to solve the numericals. At the end, I'm going to check your notebook also at the time of submission. So whatever we are discussing in the lectures, derivation, numericals, it must be in your notebook. All the calculation part, all the formulas. So please prepare the notebook. This is the problem for your exercise. Start solution and tell me the answer directly. Read the statement carefully or I will help to read the statement and try to solve the problem. See, a bar 3 meter long and 60 mm diameter. Bar means it is circular in cross section. Please keep in mind, a bar of 3 meter long and 30 mm diameter. It is subjected to load of 200 kilonewton. It is subjected to load of 200 kilonewton find stress and elongation. Find stress and elongation when load is applied gradually. Find stress and elongation when load is applied gradually. Full stop. What will be the maximum stress and elongation? What will be the maximum stress and elongation if load had been suddenly applied? If load had been suddenly applied, take capital E is equal to 200 gigapascal. Means only one bar is there. It is having the diameter 60 mm, length is 3 meter, and that particular bar, it is subjected to the 200 kilonewton external load. Initially, condition number 1, that particular bar is subjected to the 200 kilonewton gradually applied load. Then what will be the stress and what will be the elongation? On the same bar, again same 200 kilonewton load is applied, but it is applied suddenly. Condition number 1, 200 kilonewton load is applied gradually. Find stress and elongation. Condition 2, the 200 kilonewton load is applied suddenly. Again find out the maximum stress and the elongation. That means in single problem, they are interested to find out the stress as well as elongation by using the gradually condition as well as by using the suddenly applied condition. So now solve the problem and please check as per your suddenly applied load. Stress due to suddenly applied load is twice than stress due to gradually applied load. In addition to that, elongation due to suddenly applied load is twice than elongation due to gradually applied load. In suddenly condition, whatever the answer will get, that answer is 2 times answers of the gradually applied load. So solve the problem. First of all, write down the given data. Length is equal to 3 meter is equal to 3000 mm. Diameter is equal to 60 mm. P is equal to 200 kilonewton. Capital E is equal to 200 gigapascal is equal to 200 into 10 raised to 3 Newton per mm square. Similarly, P 200 into 10 raised to 3 Newton. And we have to calculate sigma. We have to calculate elongation for gradual. Similarly, we have to calculate sigma. We have to calculate deformation for suddenly applied load. Now do the calculation. Write down the case number 1. Gradually applied load. Use the formula for the gradually applied load for the stress calculation. Then use the formula for the deformation calculation. For both the condition, deformation formula will be same. Delta L is equal to sigma L upon E. So here gradually applied, and here suddenly applied. Try to represent your answer in the chat box immediately. Yes, stress due to gradually applied load. Sigma is equal to P upon A. Yes, 70.73 Newton per mm square. Delta L is equal to sigma L upon E. What will be the deformation? Yes. Stress due to the suddenly applied load, again sigma is equal to 2P upon A. So 2P upon A means we are having the, yes, what is the answer? 141.47 Newton per mm square. Please check your answer. Stress due to gradually applied load is 70.73 and stress due to suddenly applied load is 141.47. And if I will compare both the stress value, I can say that the stress due to suddenly applied load is twice than stress due to gradually applied load. If I will compare both the answers, the stress due to applied load is maximum than stress due to the gradually applied load. Do the calculation. Sigma is equal to P upon A and sigma is equal to 2P upon A. Yes, 141. What will be the elongation for the gradually applied load? Elongation for the gradually applied load 1.06 mm. Delta L is equal to 1.06 mm for the gradually applied load. Then suddenly applied load, please check. Formula will be same. Delta L is equal to sigma L upon E. Only sigma value it will be changed. Other values are yes. For the applied yes, 2.12. Please check your answer. 2.12. Yes, correct. 2.12 mm. And if I will compare this particular deformation due to suddenly applied load, again it is twice than gradually applied load. The elongation due to the gradually applied load is 1.06, but elongation due to suddenly applied load is 2 times more than gradually applied load. बघा 1.06 जर आपण डबल केलं तर 0.12 mm. What is clear about that? Therefore, we can easily say that whatever the stress, whatever the elongation is taking place suddenly applied load, it is 2 times or twice than gradually applied load. Solve the problem. Oh. Yes, do the calculation. Have this problem is very simple. Or both the conditions are made the same statement. Only single bar is there.
Sir, voice is breaking.
Yes, only single bar is there and subjected to 1 kilonewton. Initially, that 200 kilonewton is applied gradually,
Voice is
and again 100 kilonewton is applied suddenly. Wait. Now, take do not problem. I think the point. Okay, finish. Have you started with the numericals? This is the type number 1. What is the numericals? The numericals we have. This is the type number 1. Yes, now it is clear. Please check.
Yes, sir.
Okay. Okay, so these are the four numericals we have discussed, which is based on the type number one. All the four numericals are based on only gradually applied load and the suddenly applied load. In all the four numericals, we have calculated stress due to the gradually applied load, elongation due to gradually applied load, and the strain energy stored due to the gradually applied load and the suddenly applied load. All the four numericals are related to the same type, in which either gradually applied load or suddenly applied load it will be given in the statement, and we have to calculate the same parameters. That is, we have to calculate the sigma, we have to calculate the deformation, we have to calculate the strain energy, or we have to calculate the maximum strain energy, means we have to calculate the resilience. Okay, so this is about the type number one which we have discussed today, that is problems based on the gradually and the suddenly applied load. Okay, have you understood this particular part? Anybody having any part?
Sir, voice is breaking. Sir, voice break होता है.
Okay, okay. Now it is clear. Please check. Okay, have you understood this particular four numericals? Anybody is having any problem related to these four numericals? That is problems based on the gradually applied load and problems based on the suddenly applied load. Yes, anybody is having any problem? If you have any problem, please ask me. We'll repeat the things once again. Okay. I think there is no any problem. So we'll move to the type number two. Yes, type number two. Problems on the kinetic energy. So this is the type number two. That is problems based on the kinetic energy. We're having the formula for the kinetic energy
Sir, अजून
calculation.
पण
That
voice
is
break
kinetic.
होतोय.
Sir, voice is breaking.
Voice break होतोय sir. Sir, voice is breaking.
Yes. Now it is audible. Please check.
Okay.
Okay, so due to that network problem, again and again that voice is breaking. So I will try to take. Okay. Okay. So we'll discuss about the type number 2, that is problems on the kinetic energy. So we are having the formula for the kinetic energy calculation. It is kinetic energy is equal to 1/2 mv square. So sometimes in the statement, if the mass is given, so we can use this particular mass as it is for the kinetic energy calculation. Velocity is given, maybe in the meter per second. So that velocity or speed also we have to keep, and we have to find out the kinetic energy. So whatever the last 4 problems we have solved in the type number 1, in that we have calculated the stress value, we have calculated the deformation value, we have calculated the strain energy value. But this is also type number 2. Again, in that again we are calculating the stresses, deformation, but in many times in the statement the kinetic energy we have to calculate, and by using that particular kinetic energy we have to go for the further calculation. So how to identify this particular problem, whether it is based on the kinetic energy or not? Because in the statement the speed of that particular body or its velocity, it is mentioned in the statement in the form of meter per second, and then you have to identify that, or we can say that that particular numerical is based on the kinetic calculation. So whatever formula is in front of you, that is 1/2 mv square. So that we represent the speed or velocity which is given in meter per second. If mass is given, directly we can put that particular mass in the kinetic energy equation. If mass is not given, but load applied on that particular body is given, at that time we can use formula, that is kinetic energy is equal to 1/2, as it is. Instead of mass I can use P upon G. That capital P represents the external load applied on the body, and that G is the constant parameter, which value is 9.81 meter per second square. The value of G is 9.81 meter per second square. But if I will calculate the formula by using this particular, if I will calculate the kinetic energy by using the formula, kinetic energy is equal to 1/2 P upon G into V square. At that time, whatever V parameter is there, that V value we have to put in meter per second. That V value we have to put in the form of meter per second, because your G parameter is present in the form of meter per second square. And after this calculation, initially whenever you will get the kinetic energy, you will get the kinetic energy in the form of Newton meter per second. Newton meter per second. If I will take the value of V in meter per second and value of G in meter per second square, initially I will get the kinetic energy in the form of Newton meter per second. But what is our requirement? All the parameters should be in Newton, as well as all the parameters should be in mm. Therefore, if I convert to the Newton meter per second in mm, I have to multiply. So while solving the problems based on particular kinetic energy, the value of E as your external load, value of G is 9.1 meter per second square, and the value of E is meter.
Voice is not clear, sir.
सर वॉइस ब्रेक होता है.
Okay. Yes, now it is clear. Please check. Yes, voice is audible.
Yes, sir.
So, talking about calculation of time energy. So, putting the value of G in meter per second by putting the value of G in meter per second square, daily get the kinetic energy in the form of Newton meter per second. But what will be our requirement? We will get calculating Newton EMF per second. So to EMF we have to multiply by 2 3, and that Newton EMF we will use for your further calculation. Therefore, how this particular problem we have to define? If the statement, the speed or velocity, if this parameter is in the statement, then
Sir, break while
this particular numerical is based on energy calculation. Am I audible now? Please check. Anyone please reply.
Yes, sir.
Yes, sir.
Okay. So we are discussing about the problems of the kinetic energy, how to identify that particular problem. That is, if in the statement the velocity or speed, if it is given in meter per second, then we can say that that particular numerical or that particular problem is based on the kinetic energy calculation, because that kinetic energy we have to use and solving the problem based on the kinetic energy, or while calculating the kinetic energy, we have to use the value of V, speed. The V is also called as a speed in meter per second, and the value of G in 9.81, that is meter per second square. And from that, you will get the kinetic energy in the form of Newton meter per second. But what is our requirement? The kinetic energy should be Newton m per second. So again, we have to multiply by 10 raised to 3, and we have to then I have to use that particular kinetic. So
Voice break
this is
होतोय, sir.
about
Voice is not clear.
am I audible now? Please check. Hello. Am I audible now? Please check.
Yes.
Now voice is clear.
Yes, sir.
Yes, sir.
We'll try it once again. If it is facing again the same problem, then we'll decide whether we have to continue or not. Okay, now it is clear. Once again, please check. Am I audible
Yes, sir.
properly?
Yes, sir.
Yes, sir.
Okay. Okay. So we are discussing about the kinetic energy. Just now we have discussed. Okay, kinetic energy is equal to 1/2 mu square, and how to calculate that particular parameters. Here there is no any derivation part. Only we have to solve the numericals. Now how the numerical will be there? Let's see. Okay. So this is a statement. That particular numerical is based on the kinetic energy calculation, and I have told how to identify that. The value of speed or the value of velocity, it is mentioned in the statement in the form of meter per second. So first of all, I will read the statement and then we'll solve the problem. Okay. So this is the problem number 1. A steel rod lowers a load of 20 kilonewton. A steel rod lowers a load of 20 kilonewton at a rate of 2 meter per second. A steel rod lowers a load of 20 kilonewton at a speed or at a rate of 2 meter per second. Full stop. The length of rod is 15 mm. The length of rod is 15 mm. Full stop. What will be the stress developed and the maximum elongation? What will be the stress developed? That means we have to calculate the maximum stress induced. And what will be the maximum elongation? Means we have to calculate the deformation. Assume diameter of rod is 25 mm and capital E is equal to 2 into 10 raised to 5. If you read the statement, in this particular statement, there is no any word like load is applied gradually, load is applied suddenly. Like that statement or like that word, it is not mentioned in the statement. So this particular numerical will not be solved by using the concept of type number 1 numericals, whatever the 4 numericals we have discussed in the last lecture or in the today's lecture. By taking the reference of that numericals, it is not possible to solve this particular numerical, because whatever the 20 kilonewton load is applied, it is not applied gradually, it is not applied suddenly. The statement is totally different. What is that statement? A steel rod lowers a load of 20 kilonewton at a rate of 2 meter per second. Lowers means that particular load So whatever the 20 kilonewton load is there, it is lowers. Lowers means maybe it is moving in the downward direction. By which speed? Its speed is 2 meter per second. Full stop. The length of rod is 15 mm, and due to that particular 20 kilonewton load, how much amount of maximum stress developed in the rod, as well as how much amount of elongation is taking place. And for further calculation, take the diameter is equal to 25 mm and take L E is equal to 10 raised to 5 Newton per mm square. So here,
Sir, voice is
in this
breaking.
particular
Voice break होतोय sir पुन्हा. Voice is not clear.
Yes, sir. Voice is breaking.
Yes, sir. Break व्हायला.
Break व्हायलाय sir. आवाज.
that is clear. Please check. So maybe so many network issues there, so that problem is arises. Now it is clear. Whether
Breaking,
audible or
sir.
not.
It's breaking, sir. Not clear.
Again,
Not clear sir.
okay. So first problem is there.